This is a simple aluminium plate, a platter, large platter. It's about 2 kilograms heavy. I propose to lift it without anything underneath and anything over it. I mean anything material. We will be using the magnetic field created by the current to lift it. There is a secret in it, there is a trick in it. Maybe I should show you before.
What's the noise?
Oh, it's a platter vibrating. It was trying to lift but couldn't, but now it did. And as you can see, there's nothing underneath, and of course nothing over it.
Underneath the plate is a coil of very thick wire, about 2.5 centimeters thick to be exact. When you pass an 800 amp alternating current through this coil, it creates a constantly changing magnetic field around it. This in turn induces a current in the secondary coil, which in this case is formed by the aluminium plate. Like all electromagnetic fields, the direction of the one induced in the primary coil follows Fleming's right-hand grip rule. Point your fingers in the direction of the current flow, and your thumb will point to the north of the magnetic field.
And since the direction of a given magnetic field is given by the direction in which current rotates in the coil, we'll have the current moving about in one way, creating the equivalent of a magnet with the north pole upwards, and afterwards you will have the current flowing the other way, and the north pole would be this time downwards. So you have actually the equivalent of a magnet would be shifting up, down, just beneath the plate. And we've seen that motion of a magnet is sufficient to induce a current. The current is actually induced here, or in any other circuit I could find. Here's one. See? The light bulbs are shining now. Stronger when closer. A bit farther it's less, but there still is current. There's current, the possibility of current everywhere. The possibility of current has a name in physics. It's called an electrical field. It's a possibility of current in a conductor. And the proof that there lie currents in this platter is the fact that the platter has grown hot, extremely hot. If I put my hand on it, it will sizzle like a good steak. Here's water. As you can see, it boils very quick. The platter is at around 250 degrees Celsius. Very hot.
The reason the plate gets hot is because it resists the flow of current, creating a kind of friction that converts some of the electrical energy into heat. And in this experiment, there's a lot of current to resist. The setup is actually a simple transformer, but without an iron core. If you ignore losses, the current in the secondary coil is calculated by multiplying the input current by the ratio of turns in the two coils. In this case, the secondary coil or plate acts like a single loop, and so to find out how much current's flowing in it, you have to multiply the input current of 800 amps by the number of turns in the primary coil. If the transformer was 100% efficient, 4 turns would mean 3,200 amps, 5 turns 4,000 amps, and so on. The current then induces a magnetic field in and around the plate, causing it to float or levitate.
Why is it levitating over? That's because I have here a current, a circular current, and current yields a magnetic field. So I don't have one magnetic field, but 2. So the 2 magnets are heads on, north pole towards north pole or south pole towards south pole, but they're always repelling each other. That's the trick of it. And that's a way to levitate something, a conductor, without anything material under it and nothing over it, of course. It is